Let's say we had a count x with the binomial distribution with n number of observations and p probability of success. How would we find the expected value or the mean and the standard deviation of x? Well, first of all, let's try to simplify this problem and make it so that x would be the number of successes in a single trial. So we have x and the probability of x. And in a single trial, we can either succeed or fail. So 0 would be if we fail and 1 is if we succeed. Let's say P is a probability that we succeed and then Q is a probability that we fail. In this example, P plus Q is equal to 1 because the two possible probabilities must equal 1. And we also know that Q is equal to 1 minus P. Well, our expected value for this trial, this one trial, is equal to 0 times Q plus 1 times P, which gives us P. Well, we know that this is the expected value for just one trial, and in binomial distribution, we have a bunch of trials with the same probability. So in order to find the expected value for, let's say, y, given that y accounts for all the trials, so each trial that is exactly just like x, so we have the expected value of y equal to the expected value of x1 for one trial plus x2 for two trials, x3 for three trials, etc., until we have n number of trials. Well, we know that this is basically equivalent to the expected value of one trial plus the expected value of the second trial plus the expected value of the third trial, so on, for n number of trials. Based on what we have over here, because this is equivalent to the expected value of x, we can pretty much write this as p plus p plus p, etc., until you get your total of n different trials, or n trials, but each trial has the same probability of succeeding. And then since we are doing this n number of times, you can write this as np. So now we know that our expected value for a binomial distribution is just the number of trials multiplied by the probability of success.